Good morning. My name is V. Selvam, Assistant Professor, Mechanical Engineering. Now I discuss about the advanced IC engines, the Unit 2, the compression ignition engines. First one, the stage of combustions. The combustion in a CA engine is considered to be take place in 4 stages. It is divided into the ignited delay period, the period of rapid combustion, the period of controlled combustion, and the period of after burnings. First one, ignition delay period. The ignition delay period is also called the pre- preparatory space during which some fuel has already been admitted but has not yet ignited. This period is counted from the start of injection to the point where the pressure time curve separate from the monitoring curve indicated as start of combustion. The delay period in the CA engine exerts the very great influence of both engine design and performance. It is of extreme importance because of its effect on both the combustion rate and knocking, and also its influence on engine starting ability and the presence of smoke in the exhaust. The fuel does not ignite immediately upon injection into the combustion chamber. There is a definite period of inactivity between the time when the first droplet of fuel hits the hot air in the combustion chamber and the time it starts through the actual burning base. The period is known as the ignition delay period. The physical delay. The physical delay is the time between the beginning of injection and the attainment of chemical reaction conditions. During this period, the fuel is atomized, vaporized, mixed with air and raised to its self-ignition temperature. This physical delay depends on the curve of fuel, that is for light fuel, the physical delay is small, while for heavy viscous fuels, the physical delay is high. The physical delay is greatly reduced by using high injection pressure, high combustion chamber temperature, and high turbulence to facilitate breakup of the jet and improve the evaporations. Chemical delay. During the chemical delay, reactions start slowly and they accelerate until inflammation or ignition takes place. Generally, the chemical delay is larger than the physical delay. However, it depends on the temperature of the surrounding, and at high temperature, the chemical reaction are faster and the physical delay become longer than the chemical delay. It is clear that the ignition lag in the SA engine is essentially equivalent to the chemical delay for the CA engine. In most CA engine, the ignition lag is shorter than the duration of ignitions. Stages of combustion. The second one, period of rapid combustion. In this stage, the pressure will rise rapidly due to the delay period. The fuel droplet and had the time to travel over themselves in a certain area in combustion chambers. The fresh air is surrounded over the droplet. The period of rapid or uncontrolled combustion is measured from the point at the end of the delay period to the maximum pressure point on the indicator diagram. In this stage, one third of the heat is generated. The third one, period of controlled combustions. This stage is called the probable diffusion flame. After the completion of the rapid combustions, the third stage is followed. At the end of the second stage, the temperature and pressure will be too high. The feeble droplet are injected at the last stage of burn, which enter and they control the rise of the pressure by injection rate. Then fourth one, period of after burning. Theoretically, in the above the three stage itself, combustion process gets over. But practically, due to poor distribution of fuel particles in combustion chamber, forms the continuous combustion during the part of the expansion stroke. The next one, knocking in CI engines. Knocking in SI and CI engine are fundamentally similar. In SI engine, it occurs near the end of the combustion, whereas in the CI engine, it occurs near the beginning of combustion. Knock-in CI engine is related to delay period. When the DP is longer, there will be more and more accumulation of fuel droplet in combustion chambers. This leads to too rapid a pressure rise due to ignition, result in jumping for forces against the piston and rough engine operation. When the TP is too long, the rate of pressure rise is almost instantaneous with more accumulation of the fuel. Knocking in SI engine and CI engine for the diagrams. The next one, normal combustions. Under ideal condition, the common internal combustion engine burns the fuel air mixture in the cylinder is an orderly and controlled fashion. Abnormal conditions. Then the factor affecting delay period. Many design and operating factors affect the delay period. The important ones are compression ratio, engine speed, output, automation of fuel and duration of injections, injection timing, quality of the fuel, intake temperature, intake pressure. The affecting delay period, compression ratio, first one, the TP decreases with increase the CR. The engine speed, the TP decreases with increase the engine speed. The power output, the DP decreases with increase the power output. Fuel automation, DP increases with fineness the automations. Fuel quality, the TPs decrease with higher cetane number. Intake temperature and pressure, TPs decreases with increase the temperature and pressure. TP means delay period. The injection timing, at a normal engine condition, the minimum delay occurs with the start of injection at about 10 to 15 PTC. In increases in the delay time with the earlier or later injection timing occurs because of the air temperature and pressure during the delay period. Injection quantity. For a CI engine, the air is not throttled, so the load is varied by changing the amount of fuel injected. The direct injection type, the indirect injection type. The shallow depth chamber, the depth of the cavity provided in the piston is quite small. Large engines running at low speed, the cavity diameter is very large. Hemispherical chamber also smaller. However, the depth to diameter ratio for the cylindrical chamber can vary to give any desired case to give better performance. The direct injection type, the design is recent diesel engines. This is a modification of the cylindrical chamber in the truncated cone with the base angle of 30 degree. The swell was produced by masking the valve for nearly 180 degree for circumference. The squares can also be read by varying the depth. Toroidal chamber. The idea behind shape is to provide a powerful quiz along with the air movement similar to that of the bar smoke ring within the toroidal chamber. Indirect injection type. Indirect injection type. In this type of combustion chamber, the combustion space is divided into the two parts, one part in the main cylinder and the other part in the cylinder head. The feeble injection is affected usually into that part of the chamber located in the cylinder head. These chambers are classified further into spiral chamber in which compression swell is generated, pre-combustion chamber in which combustion swell is induced, air cell chamber in which both compression and combustion swell are induced. Divided combustion chamber is defined as one in which the combustion space is divided into two or more distinct comba- combar- compartments connected by restricted passages. This creates considerable pressure between difference between the during the combustion process. Indirect engine type. The spill chamber. In this chamber is located in the cylinder head. 50% of air is transferred during the compression stroke. Throughout the chamber to the cylinder, which enter the chamber in a tangential direction, so that the air coming into this chamber is given strong rotary movement inside the swell chamber, and after combustion the product rushes back into the cylinder through the same throat at much higher velocity. Pre-combustion chamber. It is consist of an antechamber connected to on the main chamber through the number of small holes. It is located in the cylinder head and its volume amount for about 40% of total combustion space. During the combustion stroke, the piston forces the air into the pre-combustion chamber. The fuel is injected into the free chamber and the combustion is initiated. Thank you.